ahead, Mr.
Okay, so guys, a bit of a lead follow-on from last Thursday. We're looking at this idea of congruence and similarity. Who can remind us again what we mean if two things are congruent?
Congruent is exactly the same.
So congruent means that two things are exactly the same. And what does similar mean?
In the same ratio.
Yeah, so it means in the same ratio, but not necessarily the same size. And so this is, I've just written these here. We're not going to go through these again, but these are the four. There's 4 different proofs for how to prove if things are similar or if triangles are similar. So this is for triangles. So similar. This is for similar triangles. And this is for congruent triangles. So these are the proofs we use, and we did do some stuff last lesson with how to prove if things were similar. But we kind of looked just really at usually they're just pretty straightforward ones where we are going to start seeing ones, and this happens when you do in year 11 and 12 too, where it's not so like you can see the ones I've got on the board over there, not so easy to see which rules apply. So it's kind of a bit more problem solving type questions we're heading into. So these are the proofs. So part of it's having to choose the proper proof, and then we have to set up and actually state which one of these it is, and then how we know each of these are similar or the same. Often these, that's why I've listed these here, often this links in as well with these different types of angles that we have. And I know you guys have done a lot of this. We haven't done it really a lot with me, but I know you guys would have looked at this before in year 7 and 8. So I just want to list these types of angles here that often come up as well, because you'll need to be able to use these in your proofs. If you have an angle, we have seen this one a bit in trigonometry. What are those types of angles called? There's one there, alternate. Now, guys, it can help with these if you kind of look for that shape. So I know when I teach this in year 7 and 8, it's kind of, you look at like the Z angles, so you might have seen that as like Z angles, or Zangles. You obviously see Zangles, Kangles, and Fengles. These ones here, these are co-interior. So again, we've seen that a little bit in trigonometry as well. We often think of those as Kangles. So it just helps, like when you're trying to identify, it helps to look for that shape. That's why they help, because we're looking for that Z shape here, we're looking for the C shape here. These ones we can refer to as Fangles, and they're corresponding. Yeah. So corresponding, and they're called, you can look for that F shape, so you can remember them as being Fangles, but these ones are kind of like these things here are kind of like the colloquial language we use, where you can't use them in your proof, but it can help to identify which ones they are. And then you got these ones, these are called vertically opposite, and you're looking for that, like, I guess, X, sometimes call them X angles as well, so again, you're kind of looking for one, we're kind of looking for the right shape. These come up a lot. So vertically opposite. These come up a lot in proofs, in these geometric proofs, when you're trying to prove whether angles are the same. And so you have to, but if we do use one of these in a proof, and this is where we're sort of extending from last time, where we didn't really use these, because we were just told they were the same. Often we were just told angles were the same. We didn't actually have to do anything to say, we didn't have to really necessarily give a reason. It just said angle A is the same as angle B or something. But we do have to start now to think of what the reason is. So let's look at, if we can move the camera, Justine, over to this side, please. So if we look at this first example here, I've used the notation. Remember, you have the 3 horizontal lines means what? Congruent. And remember, the vertical lines means similar. Yeah. So we just need to remember that notation as well. So we want to prove that this triangle, here's this triangle on the left, is congruent to the triangle on the right. So we want to prove that they are the same. If this one is not so obvious as the ones we've seen previously, because we're not really told exactly which length we're trying to prove are the same one, or which angles we're trying to show are the same. But can anyone, from that list of, like we had on the other side of the board of congruent proofs, which one, we obviously can't use side, because we don't have information for all the sides.
We use alternate.
Yeah, Calvin, what could we use?
Use 2 lots of alternate and vertically opposite to prove all the angles.
Yeah, so we know these angles here are alternate, and these are alternate, and we actually also know these are vertically opposite, so we actually can find all the angles. So the angle side one would be, because we only know one side here, so we can't do any of the ones that we'd use more than one side, could we? That's a good sort of giveaway. So we know it's going to have to be angle, and side. And this is where we have to start using the proper, so you do need to be quite formal with how you set